Okay, so we're going to talk here about radians and degrees. So first of all, we know in a circle that there are 360 degrees. Now, that is an ancient idea from the Babylonians and the Sumerians a long time ago, because their number system had a base value of 60. Our number system has a base value of 10. So they use 360 degrees because there's a lot of factors in 360 degrees here. So you can see this GIF that is rolling around right here. We're going to talk exactly about what radians are in a minute here. Okay, so 360 degrees is good, but if you're going around a bunch of times, like 360 degrees, if we're looking at something that's 121,436 degrees, that seems like just an arbitrary, strange number. So what we're going to use instead are radians. And science uses radians a lot because radians is actually a physical distance. Okay, so if we watch this right here, this is exactly what a radian is. So what a radian is we take the radius of a circle and we draw it straight out. So we lay out a radius of a circle, and what we're going to do here is make our circle, and then we're going to take the radius right there and then lay it on the outside of a circle. And what that is 1 radian. It's the distance of the radius around the outside edge of the circle. Okay, so if we lay one down, you can see it's that distance. Now we're going to lay another one down right next to it. So if we lay another one down right next to it, that's like 2 radians. And then we do it again, and we get down to 3 radians, and oh, look what shows up. Pi radians. So that is where pi actually comes from. Okay, we can lay the radius around the circle 3.1415, and it just keeps going and going and going and going and going. And that gets us halfway around this circle. That's the distance halfway around the circle. So 2 pi radians is all the way around the circle. So if we make the circle, we've got 2 pi radians, which is all the way around the circle. Okay, so radians are a distance. Okay, we have degrees are a measurement, but we're really looking for radians as a distance. Okay, we want to talk about things in terms of a distance. It's much more efficient, makes more sense, and it's also in a base 10 here, okay? So how do we convert here? So what I'm going to show you here is if we are given our degree measures, so I'm given 135 degrees, and I want to convert to radians. Well, what do I know that pi radians is equivalent to 180 degrees, okay? So pi radians is equivalent to 180 degrees. So if I know that that's true, I can put a pi on the top and then a 180 on the bottom. And now what happens is the degrees are going to cancel out, and we're going to be left with radians. Now, a lot of times in radians, our answers are in terms of pi. So if we just simplify that fraction to 3 pi over 4, that would be the simplified version of how many radians are in 135 degrees. Okay, so very often are you going to have times where there are pi is included in your values in the radians. Okay, now what happens if we have radians and we want to go back and figure out, well, how many degrees is that going to be? So you're going to keep this same thing in mind, right? 180 and then pi. Okay, but this time we're going to put 180 on the top and then pi on the bottom. And the reason we want to do that is because this is technically pi radians, and this is 180 degrees. So the radians and the pi are going to cancel out, and then we're going to left with 5 times 180 divided by 4. Okay, and that's going to give us a value of 225 degrees. So 225 degrees is the same as 5 pi over 4 radians. Now, if you have just 6 radians, there's no pi involved, you're still going to do the same step. I'm still going to put 180 degrees on top and then pi on the bottom. And this is where you're going to have to use your calculator because pi is incorporated in the rotation here. So I've got 6 times 180. And then if I divide by pi, my answer is going to be approximately 343.77 degrees. Okay, so you can see that 6 radians is about 343 degrees, which should make sense to you, right? Because what do we say a full rotation was? 2 pi is a full rotation, which is equal to 360. Now, 2 times pi is approximately 6.28. So you can see how these values kind of come up, okay? The last thing we really want to look at, and I wanted to show you, is what happens in the first quadrant. Okay, when we're talking about the unit circle here, what happens in the first quadrant? So in the first quadrant, right, there's a good idea to kind of have these values memorized. Because if I'm going to go with this rotation right here, if I'm going to open up 30 degrees, I'm going to have the same in terms of radians as pi over 6. And then if I open up 45 degrees in my rotation, I'm going to have pi over 4 radians. And then if I open up to 60 degrees, it's the same as pi over 3. And then the 90-degree rotation, which is 90 degrees, which is straight up, is going to be pi over 2 radians. Now, these are kind of important to keep in mind, because if I'm just going to open up and rotate, for example, something like this, if I opened up over here and said, well, what is 5 pi over 6 radians? The shortcut would be, well, if I know that pi over 6, anything divided by 6 is going to be 30 degrees, all I need to do is just multiply. So 5 times 30 is 150 degrees. Okay, so there's a little shortcut that you can work on here. If you want, ask us in class and we can really help you with how to develop this shortcut right here to help you remember. Okay? All right, hope this helps.